Hello, dear aspirants. This is Dr. Sourav Sir's class. We are solving some questions from statistics. So, this question is telling us that let x1, x2, xn be a random sample from an unknown distribution with absolutely continuous cumulative distribution function CDF f. Let f naught be a specified absolutely continuous CDF for testing h naught equals to fx equals to f naught x for all x against h1 wherever fx is not equals to f naught x for some x. So consider the following two test statistics. So they are t1 comma n, that is equals to supremum of x belongs to R, and mod 1 by n, that is 1, yeah, sorry, 1 by n, and there will be summation I equals to 1 to n. There is I, and suffix we will get xi, which is less than equals to x, minus fx, sorry, f naught x mod, and our t2n is equals to supremum of x belongs to R, here is n, into summation of 1 by n, and the things which is written in the upper side. So wherever I is what, that is like a characteristic function. So this is 1 whenever xi is less than equals to x, and 0 whenever xi is greater than x for I equals to 1 to n. Then which of the following statements are true? The options are t1n IP goes to 0 as n tends to infinity under h naught. T2n goes to 0 by p as n tends to infinity under h naught, and option 3 is telling us that limit n tends to infinity pf when a probability when our t2n greater than 1 equals to 1 for all f, and our option 4 is telling us that t2n converges in distribution to a degenerate real valued random variable under h naught. Okay, so this is the given question to us. So to analyze the problem, we evaluate each statement using the concepts of empirical distribution functions, convergence in probability, and distribution. So the given things is this. So now our statement 1, now we are going to evaluate the statement 1, which is telling us that T1n, this is going to 0 as our n tends to infinity under h naught. So our T1n is the supremum of the absolute difference between fnx and fx, f naught x. We know that by the Gilvenko-Cantelli theorem, our fnx will go to f naught x. We know that uniformly in the probability under h naught. Thus, our T1n goes to 0 in probability. So, our option 1 is the correct is a correct option of this question. So, now we have to evaluate our option 2. So, now so option 2 is telling us that T2n goes to 0 as n tends to infinity under h naught. So, our T2n is what? My T2n is equals to n supremum of supremum wherever x belonging to R, that is my fnx minus f naught x. Yeah. So while the while our fnx is going to fx or tending to f naught x uniformly under h naught, the multiplication by n causes t2n to diverge to infinity as n tends to infinity, unless the difference is exactly 0. So the t2n is not going to, sorry, the t2n is not going to 0 as n tends to infinity. So our option 2 will be ruled out. Now we have to think for our option 3 and 4. Okay, the option 3 is telling us to calculate the limit. Okay, we are going to use this. Okay, so limit n tends to infinity, probability when our t2n is greater than 1 will be 1 for all f. Okay, so as since our t2n is this, so and our fn x is going to f naught x under h naught, our t2n grows unbounded as n tends to infinity. Yeah, that's correct. So then the probability will go to 1. So this is also a correct statement. So our option 3 is a correct statement. Now we have to think about our option 4. As T2n converges in the distribution to a degenerate real valued random variable under H0. For T2n to converge in distribution to a degenerate variable, it must stabilize to a fixed value as n tends to infinity. However, T2n grows unbounded under H naught as n tends to infinity. So it does not converge to a degenerate random variable. So our option 4 will be false. So the correct answers are these 3 and 1. Okay. Hope you understood, guys. Thank you.